Hey, it's Linford here, and in today's video we're going to be discussing applications involving percentages to linear equations. As you can probably tell from my very messed up voice, I'm a bit under the weather, so I'm going to try to get through this as clearly as I can. Hopefully you can understand me, because in today's video we're going to be figuring out how to find percentages and other missing information using percentages. We're also going to be trying to turn sentences in English into equations. And then we're going to figure out how we can apply percent markups and markdowns. So first up, we want to review finding percentages. So here's the problem. What percent of 500 is 30? Meaning if I had 500 items and I took 30 of them, what percent of 500 did I take? Did I take 50%? Did I take 10%? Did I take 20%? Did I take 15, 18, 17.5%, whatever. I'm trying to figure out what portion of 500 is 30. Now there's a couple ways of going about solving this and a couple ways of thinking about percentages. One common way that most people learn in middle school is the ratios test, or the ratios technique. This is commonly referred to is over of equals x over 100. Now I don't particularly care for that. What I like to think of it as is you're going to set up some ratios. You want to take a portion of your total and put that over your total amount. And you're going to set that equal to whatever the percentage is over 100. So you could set up this proportion and ask yourself, okay, what is my total amount? What is the full quantity I have? And that's 500. So that's my denominator here. What's the portion that I'm taking? Well, I'm taking 30 of the 500. So that's the portion. Now you're always going to have 100 here. And then for percentage, what do I put there? Well, that's what I'm trying to find. I'm trying to figure out what the percentage is. So since that's my unknown, I put x there. Now you could then go ahead and solve this. I would be using the clearing fractions method. You can multiply both sides by 500 over 1. We get 30 equals, let's see, 500 over 100 is 5, so 5x, and 6 equals x. 6% is what 30 out of 500 is. So if I had 500 items and I took 30 of them, I've only taken 6%. That's a rather small quantity. So that's one way you could go about finding a percentage. However, the method I like to do best is just write an equation, because this fits in so much better with all of our techniques of going about and turning a sentence that's in English into a mathematical equation. So when I look at this sentence, I see what percent, so I'm trying to find a percentage of 500 is 30. I see that keyword is. I know that that means I have an equal sign, so I have an equation. So I'm trying to find what percent of 500. Remember, the word of is a key word for us. Of implies multiplication. It means that you're going to be multiplying two things together. And in fact, we're multiplying a percent and 500 together to get 30. So if I had to set up this equation, I have my equal sign. To the right of the equal sign is 30. And to the left of the equal sign, I'm going to multiply together 500 and the percentage. I don't know what that is, so I'm going to leave it as x. So how do I figure out what x is? Well, I just divide both sides by 500. So I get x equals, oh boy, 30 divided by 500 is 0.06. Okay, couple things to keep in mind of what's going on here. When solving the ratios method, you found x equaling the actual percentage. The ratio here, you're going to get the actual percentage as a percent value. When you solve an equation, we actually can't do mathematics with the percent value. We have to turn the percentage into a decimal. And remember, any percentage is out of 100. So when you see 0.06, that's the same thing as 6 over 100. because we're in the hundredths place, or 6%. So when you do the equations method, your answer is going to be the decimal version of the percent. Because this decimal, I can actually do mathematics with this. I can add, subtract, multiply, and divide values with this. This is helpful to me. This is not. So that's why I really like the equations method. It spits out what the percentage is as a decimal and allows me to actually do some math with it. If I want to turn the decimal into the actual percentage, all I have to do is move the decimal place over 2. Okay? Because, again, we're taking whatever this value is out of its decimal place. So I'm in the hundredths place, so I have 6 over 100, which is 6%. Hopefully it's starting to come back to you, but again, just that little trick can be just move the decimal over 2 places and you have the percentage value if you wanted. Okay, let's try some practice problems of turning English sentences into equations. What percent of 240 is 12? Okay, find that keyword is. That's your equal sign. So if I set up my equation, got the equal sign, what comes to the right of it? 12. Now what comes to the left? I see that keyword of. That means multiplication. I'm multiplying a percentage and 240 together. So let's take 240 times x equals 12. Now what I want to do is solve for x. So I divide both sides by 240. And we get x equals 0.05. That is the decimal version of the percentage. That's the value I can work with. If you wanted to see it as a percentage, like an actual thing with a percent sign, we move the decimal over 2 places, and we get 5%, okay? So if I had 240 items, and I took 12 items away from that, I've taken away 5%, a relatively small value. All right, let's try number 2. A number is 15% of 160. Is, first keyword we got to find. There's our equal sign. Then we have a number. Well, I haven't specified what that is, so that's my unknown. That's going to be x. So a number x equals, then we have 15% of 160. That means I'm multiplying together 15% and 160. Now keep in mind though, I can't do anything with 15%. When it's a percentage, I can't work with that. I have to put it as a decimal. Remember, 15% is 15 over 100, which is 0.15. We just moved that decimal place 2 over, okay? So x equals 0.15 times 160. Now let's see, if we multiply those together, we get x equals 24. So if I had 160 items and I took 15% of those 160 items, that means I've taken 24 items, all right? When we're bouncing around between percentages, total values, and the proportional value, really try and keep in mind what's going on. It's like we had 160 products, and I've taken 24 of them away. That means I've taken 15% of the products away. All right, why don't we try doing this one on our own? Let's pause the video, take a couple minutes, circle some keywords, and see if you can come up with what this equation is going to be. The value 18 is 30% of what number? Pause the video, take a couple minutes, and we'll come back after that. All right, well, hopefully you had some time to think about this, but the keywords here really are starting to stand out. First thing we got to find is, because that's our equal sign. Now, what comes to the left of the equal sign? 18. Very, very simple. What comes to the right of the equal sign? Well, we're going to take 13% of, there's our operation, a number. There's our unknown. So if we start building this equation, we're going to have 18 on this side of the equal sign. On this side, we're taking 30% of, so multiplication, a number, an unknown. So that's going to be x. Really, these word problems or these sentences aren't that hard to figure out once you start diagramming them and putting them together with these keywords. Now again, can't do anything with the 30% right now, so we're going to change that into a decimal as 0.30x. And if I want to figure out what x is, very simple, divide both sides by 0.30. So 18 divided by 0.30 is going to give us 60. That's x. So it's kind of saying, in the initial problem, you had some unknown quantity. So you had some collection of items, and you took 18 of them, and you're told that that's 30% of the total. You don't know how many items there are in total. You just know you took 18, and that happened to be 30%. So what we found with x is we figured out what the total value was. Turns out there's 60 items, and we took 18 of them, or we took 30% of them. That's the same idea. So hopefully these quantities are starting to make sense. Let's try to do a little trickier word problem. Okay, this is a very common type of situation, and many of you that like to go shopping probably find this a bit familiar. So in Michigan, we have a sales tax, and the sales tax is 6% of the cost of a purchased good, meaning you go into a store, and if that store collects sales tax or charges sales tax, they're going to take 6% of whatever the item you have is and add that onto your bill. So you got to pay for the item, plus you got to pay an extra 6% of that as sales tax. So if Mr. Linford went in to a store and bought a coffee maker for about $125, how much did he have to pay in taxes? So whenever you have a rather elaborate problem, what I like to do is really, when thinking about this problem, break it down into a very, very simple problem. We're taking 6% of the $125, and we're trying to figure out what that is. So I'm going to write down a simpler way of thinking about this. What is 6% of 125? It's easy as that. That's what we're trying to do. I'm buying something for $125, and I know that I'm going to have to pay whatever 6% of that is. So that's ultimately what is going on in here. Forget the whole setup of the problem. Forget what's going on. Really just try and think about the quantities. So if I had to turn this into an equation, find the keyword is, there's my equal sign. What comes to the left, or I'm sorry, what comes to the right, 6% of 125, 6% of his multiplication, 125, and what comes to the left of this? Well, there's no real keyword that's putting anything there, but really, it's just going to be x. We're going to do an operation that's going to spit out x. And what is x? X is 6% of that 125. We're trying to figure out, if you have $125, how much is 6% of that? So, again, can't do anything with the percentage, so I'm going to turn that to a decimal because I moved the decimal over 2 places. I'm going to multiply that by 125, and let's see what we get. I believe that's $7.50. So, if I'm going to go and buy this coffee maker, I have to pay $125, and then I have to pay an additional $7.50 in taxes. So altogether, my total bill is going to be, I believe, what's that, $132.50. So again, this is how we're taking something rather complicated and breaking it down into a much simpler way of thinking about it. That's a great problem-solving technique. Ignoring the whole setup, trying to get rid of some unnecessary information, and really think about, okay, I got 125 of something, I got to figure out what 6% of that is. So what is 6% of 125? I really like this technique, and I think it's going to make your work a lot easier for you. All right, let's try another one. Andrea spends 20% of her monthly paycheck on rent each month. So she gets some amount of money, and 20% of it she pays into rent. By the way, that rent payment is $950. So she gets some amount of money, and she takes 20% of that, which is $950. So we're trying to figure out, what is her monthly paycheck? We're trying to figure out how much money does she make in total, where we can take 20% of that and get $950. What I'd like you to do, take 30 seconds, pause the video, see if you can come up with a little sentence like we did before, where we took this very complicated expression or very complicated problem and turned it into a simple sentence. See if you can do that right here. Okay, hopefully you had some time and were able to think about this, but a way of structuring the sentence is 20% of a number is 950. So we don't know what the total amount is. I don't know how much she makes each month. However, I know that 20% of whatever that value is $950. This setup is actually pretty easy to work with because we have our equal sign. To the right of it is 950, and to the left of it, we're doing our multiplication, so we're going to take 20%, I'm putting that as a decimal, of a number. I don't know what that number is, so it's just going to be X. So here we go. We're taking 20% of some large value, and then we're going to get $950. So let's divide both sides by 0.20, or 0.2, and we get X equals $4,750. That should be how much money Andrea is making in a month. So then 20% of that is going to be $950. Hopefully these quantities are starting to make sense and that you're getting more comfortable taking something complicated and turning it into a much simpler sentence. So let's try this next one. Let's read through the problem, identify what we're trying to find, and then try to see if we can write a sentence sort of like we did before. So in order to pass an exam, a student in this particular situation must answer 70% of the questions correctly. So they must get a 70% on the test. If answering 42 questions correctly results in 70% of a score, how many questions are on the test? So the test has some unknown quantity of questions. Maybe it's got 80 questions. Maybe it's got 100 questions. I don't know. It's got some unknown number of questions. But if we took 70% of those questions, that's going to be 42. So go ahead, think about how we can write this as a sentence and see how we can structure the setup. Remember, we don't know the total, but if we took 70% of that, we should get 42. Pause the video, take 30 seconds, see what sentence you can come up with. All right, well, hopefully you're starting to see that this actual setup is very similar to the previous problem. And in this situation, we're taking 70% of some unknown total, and we're resulting in 42. So I would say 70% of a number, some unknown number, is 42. That's the relationship I'm seeing here. So there's my equal sign. To the right of it is 42. And to the left of it, we got our operation. We're taking 70% or 0.70 times a number, X. We don't know what that is. So if we take 70% of this large quantity, we should get 42. So let's divide by 0.70. We're going to get X equals 60. So that means that there are 60 questions on this test. And if we took 70% of 60, that means we have 42. Okay, hopefully these are starting to make sense. You're feeling comfortable with writing the sentences and writing these types of setups. These setups are going to be important now as we start to look at things that are called markups and markdowns, where we take a percentage and we alter the price of something or the quantity of something. So when working with a markup or markdown, you actually come across these very frequently in your everyday lives, especially those of you that really like to shop. So a markup we're going to define as a percent of the original increased. So that means we're taking an original quantity, such as in most cases a price, the price of something, and we're taking a percentage of that price and we're adding it onto it. So this is very similar to a business. So it's kind of like a business increasing the price of a good. So this is similar to a business is going to get a certain item that they order from somewhere, and what they're going to do is they're actually going to go and increase the price of that item to actually make a profit. So that's a markup. Now, a markdown is something we actually come across very frequently. This is a percent of the original decreased. So that means we are taking a percent of an original price and we're subtracting that off. We're dropping it off a certain amount, okay? So this is going to be very similar to a sale, okay? When a business takes a certain percentage off the price. So this is like a discount. Think about a sale, or you get a coupon in the mail or something. That's what a markdown is. So let's try a couple practice problems. In this first situation, we have a very popular issue that many college students face. If you go to a college bookstore, you are most likely going to see a textbook that you need for class sold 28% more expensive than it will be if you purchased it online. So if you go to a bookstore, the typical national standard is that what you find at the bookstore is going to be about 28% more expensive than if you bought the book online. So you go to the bookstore and you find your textbook for a certain class, and it's going to be $180. So you got this book in the store that's for $180, and you want to figure out how much could you potentially get it for online. What I want us to do is work through the setup to what's going on with these different quantities. The first thing that we want to do is really identify what are we trying to find. And we are trying to find the original price online before the markup. So there was a price online, and that was what we're going to call the original price. So let's label the original price is the online price. And what we're going to do when we have markups and markdowns is we end up with a new price. There was some original value, then you either added onto it or subtracted off of it, and you're going to get a new price. That new price is the $180 that we're seeing in the store. So there was an original price, and you can probably tell that this is a markup problem. We took that online price and we added some stuff onto it to get to the new price of $180. So how do we set this problem up? Well, I like to do what's called a verbal model. I like to try and think about how are the quantities all related. So we have the original price. And then what we did was we applied a 20% markup. So we increased the original price by 28% of it, and we ended up with the new price. Well, this actually kind of is the setup of an equation that I want. So the original price, we don't know what that is. That's what we're trying to find. That's going to be X. Plus 28% markup. Let's come back to that in a second. And let's fill in the right side because that's pretty easy. The new price is 180. So the question now is, how do we set up 28% markup? Well, we have to ask ourselves, what did we take 28% of? Did we take 28% of 180 or 28% of the original price X? Well, it should be fairly obvious that we took 28% of the X, the original price. The bookstore is trying to figure out how much to sell the book for. So do they know to sell it for $180 and that's 28% of what? No, they don't. What they're doing is they're taking what the original price is, they're figuring out what 28% of that is, and they're adding that on. So the markup really is always applied to the original price. So let's take 28%. Oh, my stylus is starting to die on me. Let's take 28% of the original price, so 28.28 times X. So that's our markup, and we're going to add it on to the original price. So let's get some room to do our work. The equation is X plus 0.28X equals 180. And so if we combine like terms, remember there's an imaginary 1 out there, we get 1.28X equals 180. If we divide both sides by 1.28, we get X equals 140.625. That is the price that we're going to find it online. Now, okay, I know that that's not really a price, so let's round up to the nearest cent. X, the price in the store, or the price, online, is going to be $140.63. So that's the price that we're going to have online. That was the original price, the $140.63. So we take that original price, we figure out what is 28% of that. And that is how we get to the $180. So we take the original price and we take the percentage of that and add it on. That's how a markup works. It has to be on the original price. Mr. Linford has a membership to Barnes & Noble. This membership allows him to get 10% off the price of his books. However, the membership costs an initial fee of $20. Now, because Mr. Linford really loves books and buys a lot, which is true, I really do love books and I buy way more than I should, he decides to get the membership. During the holiday season, Mr. Linford uses 10% discount and spent $247.50 on books. So that was the discounted price I spent on books. Was the membership worth the $20 Mr. Linford spent? So, in this problem, let's think, what are we trying to figure out? Part of this idea is, what does it mean that was it worth it? Meaning, did I save more than $20? So in reading this problem, what we're trying to do is, we want to first figure out the original price. We want to figure out what that original price of the books is, okay? That way, once we know that original price, what we want to do is then see if it is more expensive than not spending the $20. Meaning, did I save more than $20? So let's do the original problem first, the initial part, and let's figure out what was the original price of the books. So let's start labeling our information. The original price, again, that's something we don't know. That's going to be X. Then we have the new price. That's going to be $247.50. You're probably thinking that I just made up these numbers. In actuality, this is probably how much I actually did spend over the holiday season. So believe me, this is about as real world of a problem as it gets. So we have the original price. We have the new price. We know that the markdown, our savings, how much we discounted from the original price, is 10%. So there was some more expensive original price, but I got a 10% discount off that, and I ended up with $247.50. What I'd like you to do is try and see if you can set up a verbal model for how we're working with the original price and the new price. Basically, how are we taking the original price and turning it into the new price? Take a minute, pause the video. Let's take about 30 to 60 seconds, and let's see if we can figure out what that verbal model might be. All right, well, hopefully you had some time to figure this out and kind of play around with the model. But the idea is we're going to take that the original more expensive price, and we are taking off, we're subtracting the 10% markdown to get the new price. So we're taking off 10% of a markdown to get the new price. Now that original price, we don't know what it is, it's X. But we know we end up with a new price of $247.50. Now the question is, how do I set up a 10% markdown? What am I taking 10% of? We're taking 10% of the original price, X. So we're taking 10% of that X value, and we're going to subtract it off, okay? Remember, markups and markdowns always work on the original price. So if we go ahead and start combining some like terms, remember there's an imaginary 1 out there, we end up with 0.90x equals 247.50. And if we divide by 0.90 or 0.9, whatever you prefer, we're going to end up with X equals $275. So that was the original price of the books, $275. Now, we figured out the first part. Now we got to figure out the second part. Was it worth it to buy that membership? So the original price was $247. The new price was $247.50. How much money did we actually save in this situation? If we went and we were trying to figure this out by subtraction, $275 minus $247.50 is $27.50. So I saved $27.50. But wait a minute, I also spent an additional $20. So let's see, if I spent an additional $20, I really just saved $7.50. And hey, what do you know? That's a savings, right? All right, it's not that much, but it's still a savings. So was it worth it to buy the membership? I think so. All right, well, hopefully these practice problems are starting to make sense and you're starting to see how the certain quantities are working together with the percentages. Again, make sure that you're able to take the more complicated word problem and put it into more simple terms. Try to kick out all that unnecessary information and really look to see, can I just try to figure out in the most basic form how the quantities are working? If you have any questions or comments, feel free to contact me by email. My email is Linford, that's Klinford, @wccnet.edu. Thanks, and see you next time.